Okay, here's the 13th question of the Project Euler, digit fifth powers. Surprisingly, there are only 3 numbers that can be written as a sum of 4 powers of their digits. For example, 1634 is 1 to the power of 4 plus 6 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4. The same thing goes for 8208. 8 to the power of 4 plus 2 to the power of 4 plus 0 to the power of 4 plus 8 to the power of 4, which will be the number itself. And the same thing goes for 9474. Well, 1 is equal to 1 to the power of 4, but this is not included because it's only a 1-digit number, so this one doesn't work. The sum of these numbers is, and the sum of the numbers above, the 3 numbers above is 19,316. So what we are supposed to do is to find the sum of the numbers that can be written as their 5th power. So, for example, what we have here is we want a number as A, B, C, D, for example, A, B, C, D, which should be equal to A to the power of 5 plus B to the power of 5 plus C to the power of 5 plus D to the power of 5. Well, it doesn't supposed to be a 4-digit number, but the power should be like this, like the number itself is consists of different digits. Those digits to the power of 5 should be, their sum should be equal to the number itself. So what you have to do is first we need to, so we don't know which numbers have this condition, so we need to check all the numbers. But what we know is that first we should separate the digits of the number. Well, there are 2 ways to separate the digits. You can divide the number by 10 and repeatedly divide it by 10 to get every digit, or you can turn the number into a string and then separate each part as a string, which is slightly easier, so I go with that one. And the numbers, the digits can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And for the sake of simplicity, I try to find the 5th power of each of these digits. So I have 0 to the power of 5, I have 1 to the power of 5, until 9 power of 5. So I will put them in an array, so later when I'm trying to solve the question in the main part that is a huge for loop that will be repeated a lot of times, so I don't need to calculate these these numbers to the power of 5 repeatedly. So I do it once, I use it later whenever I want it. So this is the main idea. It's a simple brute force question. So all I need to do is to repeat these calculations multiple times for different numbers, starting from 2 until a number that is that was the hugest number I could put in an integer. So here is the way I solve the question. So what we have is, first we need to define a variable for sum. So I just named it sum. And initially sum is 0. So if, for example, the number I has that condition, so sum is equal to sum plus I. This is one thing. And then I need to find the power of 5 of each digit of the number I. So another problem is to separate the digits of number I and find their fifth power and check if that is equal to the number itself. So if the condition above is satisfied, the number should be added to the sum. Right. So first, I define the array named pow5, which saves the power of 5 of each digit, starting from 0 to 9. And then, well, here I define the pow5 array, which is the array with its size 10, starting from 0 until 9. There are 10 numbers. And then the for loop starting from 0 until 10, so the 10 is not included. I will put in each index of that array the power of 5 of that number. So I multiplied I 5 times, so I get the so I can get the power of 5 of that number. So there are only the power of 5 of numbers 0 to 9. So this is actually 0 to power of 5, 1 to power of 5, 2 to power of 5 until 9 to power of 5. So I do not need to calculate that each time in the next for loop. So the next for loop is a for loop that goes from 2 to this huge number. Why start from 2? Because the question itself said that 1 is not included. Right. So I put each number in a string. So then each digit is a string with the size 1. And I can use the parse in function to convert string to integer. And then when I convert it to an integer, so assume that A is 1, 2, 3, 4. So what I do is I get the A, and I use integer dot parse int A dot substring like 1 and 2. So it will find me the number 2. So to use the pow5 array that I defined above, all I need to do is to set pow5 and that value. That value is the number inside the main number. So it's the second digit of that number. And the thing I wrote here gives me the fifth power of that number. So it's actually like using a function, but here instead of that I use a function, I prefer to use an array that has the power 5 of all those digits. So it makes my job pretty easier, actually pretty faster. So I do not need to calculate the power 5 of each digit multiple times. And as I said multiple times, I really mean a lot of times, because as this number is in 10 to the power of 8, so starting from 1 to 10 to the power of 8, there are a lot of digits that need to be calculated, so this is much faster. And then I find the sum of the digits and put them in sum digits. Sum digits is the sum of digits of each number. So I'll check if the sum digits is equal to the number itself. So this is a number that I want. So I set the sum to, I add that number to the sum. The sum is the main sum of all the numbers that have this condition. And then I just print it out. So this is actually a simple way to solve this question. And if you run this program, you will get to this value, 443,839. So, and this is the question and how to solve it.